Hey, Greg. Got another couple more questions for you. We actually have been out visiting more customers, and customers really like our ceramic embedded antennas, especially this GNSS one, right? Not just GPS, but the ones that cover all the global navigation satellite systems, the Russian GLONASS, the Chinese Beidou or Compass system, the Galileo, in addition to the US GPS system. But they still want to know exactly what size board do they need, what's the trade-offs. They want small. These tracking devices, they want to put them on pets and farm animals and everything. They want them small. How small can they get and still have this work?
Well, that's a good question, Paul. We've actually done some tests on that. We find that the minimum recommended board size, if you want to make sure you're covering the entire navigation system, is 70 millimeters by our 37 millimeter width. 70 millimeters long by 37 millimeters. If you have larger boards, you don't see any increase in performance, but as you make the board smaller, especially at the edges, not at GPS frequency, but at other frequencies in the global navigation system spectrum, you see a loss in efficiency. If you lose that efficiency, you start to lose data. So you're not going to have as accurate a positioning system as you desire. So we highly recommend you keep it to 70 by 37 millimeters at a minimum for best performance across all of those frequency spectrums. These guys, the current flows like such, so it needs to have a certain amount of copper in which that current can flow upon.
And then part of it is a little bit of ground space clearance there.
Yeah, you can see there's a little bit of clearance as well. Do keep that in mind. It's not a great amount. 10 millimeters on one edge, not a great amount of clearance, but it is required for that optimum performance, especially the current has to flow around it.
And where do they get all those details?
All of those details can be found on our different application notes or on the technical data sheet, for the parts themselves.
Got it. Okay. So in addition to the GPS devices where they're trying to position where the tracker is, for instance, they also want to have the communication back to the network, right? A lot of times they're using LTE Cat-M, Cat-M1, right, where they have wide-banded LTE. You know, what's the situation with that? I think LTE needs a big board, I'm hearing.
Yeah, LTE is a bit of a struggle. The current on our chip, like the 3796, travels along the length of the board like this. When you are operating as low as 700 megahertz, that's a long wavelength that you can keep in mind there. So we recommend 135 millimeters long total for your board, including that ground clearance area. Remember, they got to separate the ground clearance from the copper that actually does some of the resonating. We tried reducing that length, from the 135 millimeters. It resonates with the blue line here. You can see it's got the best resonance, the lowest VSWR, both in the lower and the upper band. If you shorten it to 120 millimeters, then to 105 and to 90 millimeters, you see first loss of resonance in the lower band, and then in fact loss of resonance